chapter, 26, the last chapter.
Or is it?
Transition metals and coordination compounds. This chapter is important. If it wasn't important, I wouldn't lecture on it, right? But this is not a chapter where a lot of other things depend on this information, which is why you're being tested on it as a take-home exam. And so there's going to be a lot of names and stuff, and you may I can't memorize all of those. You do not have to memorize anything in this chapter, okay? So just, take a breath. So the colors of rubies and emeralds. So we have a picture here of a ruby and an emerald, green and red, very intensely colored. And both of those colors are caused by the same ion, a chromium 3+ ion. So these crystals have aluminum ions in there, and about 1% of the aluminum ions are replaced with chromium 3. So in the crystal, the atoms around that chromium 3 ion create a field called a crystal field, which splits the d orbitals into 2 or more levels. Normally those d orbitals are degenerate, they're all the same energy. But this crystal field causes those energy levels to split. And when those are split, the energy transitions between those levels give us the color. So when energy is absorbed, when light strikes it, certain wavelengths are absorbed and other wavelengths are reflected because of the energy transitions between those d orbitals. So then the rest of the chapter really is explaining how that works.